In material design, there are two primary forms of visual feedback in response to touch. The first is a subtle ripple effect that radiates outward from your finger, extending to the bounds of the surface that it's drawn on. For borderless elements, the ripple extends out just enough to give you a sense of the element's size.
We sometimes call this an ink ripple because we liken it to a wave of digital ink spreading on a surface, almost like a droplet of ink falling and spreading on a piece of paper. This idea of radial motion emanating from your fingertip is a key theme in material design that we'll touch on more in Lesson 3. User-initiated radial response not only puts the user in control of the UI, but it'll make the UI really satisfying to use as well.
Now let's look at the second form of visual feedback. For smaller interactive surfaces like buttons, the surface itself can lift to meet your finger, almost like your finger is magnetically attracting that surface. So you see here that the fab rises to meet my finger as I'm pressing it.
The design support library has a built-in fab widget. It already has ripples and elevation enabled, but it's a good exercise to wire up one yourself to see what's been done for you. We're going to create this app. It has two fab widgets, one we've created by hand and one that uses the design support library. So I've gone ahead and created a new project and selected the blank activity option. In my build.gradle file, I've made sure to add the design support library as a dependency. At the core of a fab widget is an image view. We can make life a little bit simpler by using an image button. I've set the background to use the accent color and a plus button as the source image. Fab Plus is a vector drawable I've created. You could use an image with transparent edges, but it's more scalable to use a vector drawable because they can be resized without any quality loss. As you can see here, our button isn't very circular. We can do that by setting its background to be a shape shaded in our accent color. Now is also a good time to set our elevation. Because we use the background drawable, Android can use that data to calculate a shadow. We don't need it in this case, but you could create a custom outline provider to control how shadows are cast. You can see more information about that in the instructor's notes. So going back to our button, we have a button that we can click and that has elevation, but it doesn't have any ripples and it doesn't raise to our touch. Let's go ahead and add a ripple. To enable ripples, we need to change the button's background from a static shape to one that's enclosed in a ripple tag. The color control highlight is the color applied to things like ripples, list selectors, etc. The main difference between oval_shape and oval_ripple is that the ripple tag encloses our shape. The next thing we need to do is add a material reaction to the fab widget to raise it up to meet our touch. To do this, we'll add a stateless animator to run an animation when the user touches the button. In the layout, we reference a file named fab_raise that lives in the resources nm directory. We have two object animators, one for when the button is pressed and one for when it's released. Notice how we animated the translation Z property of the button rather than the elevation. The final elevation is calculated by adding the current value of translation Z to the base elevation we set in code. So this translation Z property goes from a value of 0 to 8 dips. Now if we remember, our fab button has a resting state of 6 dips. So it's going to actually go from an elevation of 6 dips to 14. You won't generally need to implement fabs from scratch, and you definitely should use the design library. But it's likely that you'll need to create custom widgets that you'll need ripples for or elevation changes.